Good afternoon, all of you. My name is Nitin Tomar. I'm a third year PhD student in the Department of Mathematics at IIT Bombay. In today's session, we are going to discuss complex logarithm and problems related to it. Okay. So let's start with a given complex number, and we know it has a polar form, right? So, given a complex number z, given a complex number z, it can be written as, we know it can be written as z equal to mod z e iota theta. Correct?
Yes,
Yes,
sir.
sir.
Uh, and this is called the polar form. Now, as or we write it as basically r e iota theta. So this theta, so this r is greater than equal to 0. Theta is in r. হ্যাঁ পায়েল কেমন আছে?
Yes, sir.
হুম Yes. While today we are learning complex logarithm, and I think my internet connection is not good today. Hello, Thangeshwaran. Yeah. So this theta is written as argument of z.
Sir,
While
I
I
cannot
cannot
see
see
your
your
page.
page.
is my screen not visible?
No.
No.
Okay, just a minute. Yeah. Is it visible now?
Yes, sir. Yes,
Yes,
sir.
sir.
Yeah. So this theta is called argument of z, and as you know, it is a multi-valued function. What is a multi-valued function? A function which takes more than one value for a given point in domain. For example, this is our starting point. So, for example, you know that let's say 1. 1 can be written as e iota 2 pi, correct?
Yes,
Yes,
sir.
sir.
And it is, so here theta is 2 pi, correct?
Correct, sir.
Correct, sir.
And but it can also be written as e iota, let's say 4 pi, correct?
Yeah.
Yeah.
And in fact, what you can have, any 2n pi iota will give you the same value, right?
Right,
Right,
sir.
So
sir.
in that sense, the complex number is 1. Like so for z equal to 1, we have that argument z is what it is, 2n pi. It is this set, yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this argument z takes more than one value, correct?
Yes, sir.
Yes, sir.
So in fact this holds for every complex number, right? You add 2
Yes,
and
sir.
pi. Yeah. So in that sense argument of z is not a well behaved function, correct? All of you agree with this?
Yes,
Yes,
sir.
sir, I
Sir.
agree.
Yeah. So in fact for any complex number, remark, in fact for any complex number z naught, let's say you have one representation r e iota theta naught, then argument z naught can be will be this set 2n pi plus theta naught, yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Okay. So in that sense this is a multi-valued function, it takes more than one value. Yes. Now, okay, so now we know the problem with the argument function, that it is not a multi-valued function. So just keep that thing in mind. Okay, just keep that thing in mind. Now let us, before starting with complex logarithm, we need to study complex exponential function, and you should know the reason why. So I am just giving you some review of argument function and exponential function before going into the study of logarithmic function. Yeah. Okay. So you know how to define log exponential function, correct? For z belongs to C with z equal to x plus iota y, which can be written as r e iota theta in polar form. How do we define exponential? E power z is defined to be ex cos y plus iota sin y. Yes or no?
Yes, sir.
Yes, sir.
Yeah,
Yes, sir.
this is how we define, right? See, because x is a real number, x and y they both are real number, right?
Yes, sir.
Yes, sir. Yes, sir.
So we know the values of, we know e power x cos y and sin y. Yes or no?
Yes,
As,
sir.
yes, as real numbers. They both are, each one of them is a real number, and you combine them in a certain way to get the e power z. That is how we define. And we know that that this is an entire function. Okay, let's write some remark. Now all of I am doing this because we have to move to the logarithmic function. So first remark, e power z is an entire function. Second is range. What is the range of exponential, can anyone tell?
Minus
Minus
infinity to
infinity to
plus
plus
infinity.
infinity.
No, not in real. In the complex it is c minus
C
0.
C
minus
minus
0.
zero.
Huh?
Huh?
It can never take value 0. Okay, and it follows some algebraic identities, which is ez ew, it will be ez plus w, correct? And ez, if you add 2 and pi iota, it will be same as ez, correct?
Yes.
Yes.
Hmm. So where Z and W belongs to C and N belongs to integer. Okay. Okay. Now let's come to the logarithmic part, which is the topic of discussion of today. Now, how do you define logarithm in the real number? Exponential and logarithm has a very special relation. Can anyone tell?
1 by
Yes.
log.
Okay, so in real setting, okay, let's start with this intuition. Okay, how do we define a logarithm? That is what we'll see. Okay, so in real setting, in the setting of real number, we know that exponential of logarithm of any real number is x, correct? Yes or no?
Yes, sir.
Yes,
And
sir.
log of exponential of x is again the exponential is the x itself. This all of you agree?
Yes, sir.
So what we are trying to say that exponential and logarithm in real setting are inverses of each other, correct?
Yes, sir.
Yeah, because see, this is what inverse is defined in set theory, right? F composed with G is identity and is same as G composed with F, correct? Yeah.
Yes, sir.
So this is the starting point. Let us start. Let us try to replicate this relation in the complex setting. Okay, this builds up our intuition that we want certain function. Okay, so what is the starting point? You'll be starting with the domain, right? Yes or no? We are in complex setting. So given a domain omega in C, we want to construct a function f. Okay, at least we need continuous, right?
Yes,
Function
sir.
continuous on omega, such that what happens, e power fz should give me z. Yes or no? At least this should
Yes, sir.
happen, right? This is what we saw from the real setting, correct? So we want to have this in our life. Now if you follow the calculation of real, okay, so real calculations. No, see, before learning any part, we should know why there should be a, what is the motivation, okay? So I'm trying to build up that motivation. I don't know if I'll be able to succeed or not, but let's see what happens. Okay. So in real calculation, we know this e power fx will be x. Yes or no?
Yes, sir.
And this fx, I can take it as ln mod x,
Yes,
because
sir.
x can be negative also. Or okay, let's try. So this is not uh, exactly correct, but I'm trying to write. Oh, I think my screen froze again. No. So somehow if you try to take logarithm both side, like, so it will be, yeah. So
Sir,
f.
your voice breaking.
Oh, is it? Actually today internet is not good here. Okay, just I will connect
सर
it.
क्लियर है, यहाँ पर क्लियर सुनता है और सुनाई देता है।
Okay. Pile, actually from your side I think voice is breaking, because when I hear your voice it is breaking. Rest of
Okay,
you,
sir.
what about the others? Am I audible clearly?
Yes sir, clearly audible.
Okay.
So sometime it breaks,
Oh, is it?
but
Uh,
now it is clear, sir.
okay. Okay. I think today we have to struggle a bit. So what if I define my fz? So by definition it should be log mod z, right? Because see, no, what I want to say is the following. How do you write your z in the polar form? You will write it as mod z e iota argument of z, correct? Yes or no?
Yes sir.
Yes, sir.
Yes,
Yes.
sir.
And this can be written as e ln mod z, because mod z is a real number, times e argument of z. Yes or no?
Yes, sir.
Yes. And this you can write it as e ln mod z plus iota argument of z, correct?
Yes sir.
Yes, sir.
So what does the common sense suggest? So for z not equal to 0, first of all we need z not equal to 0, right? Because otherwise ln, we know ln 0 is not defined. See, if z is 0, this ln mod z will not be defined, right?
Yes sir.
So common sense tells, if we want to define log z, we must define it this way: log z to be the function, I am putting some gap here which I'll fill later, to be the function log z is ln mod z plus iota argument z. Does this sound promising to all of you?
Yes, sir.
Payal, Darshana, Rajesh,
Yes,
Thangeshwar.
sir.
Yes sir.
Now, what can you say about this function? Can we say that this function will be multi-valued?
Yes sir.
Yes,
Because
Why?
its argument is multi-valued.
Exactly. See, this part is fine. ln mod z is fine. Yes, this has two part. Real part is fine, but this imaginary part is creating the problem. Correct?
Yes sir.
yes, sir.
So this is the multi-valued function. This is a multi-valued function, as we have seen. So now we know where the problem lies. Okay. So how do we do it? How do we? Oh, who is Ravi? So our aim is, so okay. Let me use some another color. Yeah. So our aim is to make this log z to be a single valued function. This should be the first step, right? Single. Do all of you agree with this?
Yes, sir.
Yes, sir.
Yes sir.
See, log z as of now it is not even a function, right? It is a relation. If a point in domain goes to more than one value, then it is not a function. We all know this. So at this current point of time, log z is not even a function, and our aim is to make log z holomorphic, and that is like a step, that is like a far away step, right? So first step should be we should make it a single valued function. All of you agree with this?
Yes, sir.
Yes, sir.
Yes,
So
Yeah.
sir.
we take capital argument of Z.
Huh, and how will we do it? You know the problem.
Yes.
The problem
Small
is,
argument Z. हाँ
huh,
की जगह
exactly.
capital argument Z.
Hmm. So okay. So the problem we know that lies with argument z. If I make argument z a single valued function, then I'm done. Okay. So yeah. So for that, what we do now, we define a principal branch of logarithm, argument z. Okay. You know the principal argument of z?
0225, sir.
No, no, that is not the principal argument.
Sir,
Minus
pi
pi
to
to
minus
pi.
pi.
Ah, exactly. And which is open and which is closed?
Minus pi
Minus
is open.
pi open.
Very good.
Pi closed.
Pi is
So you know like what is principal argument, right? So this argument value, this belongs to this interval minus pi open and pi close. So quickly let us study. See, I don't want to hurry. That is the problem with me. I will go extremely careful, because this topic is very confusing for some people. This I have seen even here in, when you do MSc and all those things, people do not get the clear idea of what is complex logarithm. So I will do it extremely slow, so you have to bear with me. Is that fine?
yes,
Yes,
sir.
sir.
Yeah. So this is my real axis, and this is my, okay, I have to draw four. So okay, so here I do one another just to make sure that we know how to measure the angle. So if I give you a complex number, can you tell me its principal argument? How do we do it? Let's say my complex number is here. Okay. So what is the argument? By definition, it is the angle between, the angle between
Real
what?
axis, real axis to that point.
Between positive real axis, correct, and z measured in counterclockwise direction, correct?
Yes, sir.
Hmm.
Yes, sir.
Counterclockwise. That is what we know when it is 0 to 2 pi. But here we have some change. Okay. So for example, if you have a point here, so this is my vector z, right? Yes or no?
Yes, sir.
So what should be the angle? This should be the argument z, right? So my argument z should be theta. Is it lying between minus pi to pi?
Yes, sir.
Yeah.
Yes, sir.
Hmm. Now, if it is here, then what can you say? This is my vector z. What should be the angle?
Lies between minus pi to pi.
Hmm. So this definition that we wrote is for 0 to 2 pi. Okay, this is no longer true for minus pi to pi. That is what I was trying to tell when you said this definition. Tell me, what should be the value?
What do
What
you
do you
mean
mean
by
by
counterclockwise?
counterclockwise?
That I will counterclockwise means घड़ी कैसे घूमती है? Clockwise, right? So counterclockwise means opposite in the direction of clock.
Okay,
Okay,
sir.
sir.
Yeah, or anti-clockwise direction. So now you measure this angle from this side. It will be some theta, right? Yes or no?
Yes,
Yes,
sir.
sir.
Yes.
Yes.
But this will
But
not be
that
But
what
what
is
is
the
the
real
real
axis?
axis?
that I'm trying to tell. So here the argument will be
Pi
Pi
minus
minus
theta.
theta.
very good, pi minus theta. Okay, and this will ensure that your value lies between minus pi to pi. Okay, now what about this? If you have something in third quadrant, so basically when you say minus pi to pi, it means when you're starting from here, you have to move counterclockwise, and here you have to move clockwise. This you must know, right? This principal argument. This is what I'm trying to show. Now if your z lies here,
But
But
it is
it is
not
not
counterclockwise,
counterclockwise,
sir.
sir.
no, that I deleted now, because that I deleted because you were taking theta between 0 to 2 pi. I wrote this just to make you realize that this is wrong. Okay.
Okay, sir.
Okay, sir.
Yeah, see, this is all what should I say, this is all class 12th mathematics, right? This we have seen in NCRT books or any other books for that matter. How to measure the angle. See, you measure it anytime. Okay, you can measure angle by any chance, but you have to restrict itself to minus pi to pi. So either you will keep on adding pi, or you will keep on adding 2 pi or subtracting 2 pi. Do you get that? You have to stay in this range, minus pi to pi. Now tell me the angle for this, the third case. So
Pi
Pi
plus
plus
theta.
no, this is where you are wrong.
3 pi by 2 minus theta.
See, okay, let us write all those answers. Pi, you said pi plus theta. I am assuming you are using this as theta, right?
Yes,
Yes,
sir.
sir.
And Darshana, what are you saying?
3 pi
3
by
pi by
2
2
minus
minus
theta.
theta.
So, pi first question. This theta will be positive, so it does not belong to this range, right? Correct. That's pi.
Yes,
Yes,
sir.
sir.
So this we cannot take. Yes or no?
Yes,
Yes,
sir.
sir.
Hmm. Now, Darshana, come. I'll come to you. Now, here is minus pi. So, what I want to say. Okay, let us see what I want to say first. Then I'll come to Darshana. Okay. So, no, Darshana, how did you measure this? What is your theta, Darshana? Darshana,
Yes,
yes,
sir.
sir.
what is your theta? I think your theta is, so this is,
Anything between 5 to 3 pi by 2.
no, no, theta should be related to this z, right?
Yes.
Yes.
For example, for pi l, she said pi plus theta because you cover pi and then you cover theta. That is why she said pi plus theta. Okay. Now, what is your theta? You are saying 3 pi by 2 minus theta. So, 3 pi by 2 is here. So, this must be your theta, correct?
Yes,
Yes,
sir.
sir.
Yeah. So, yeah. Okay.
So
So
pi
pi
minus
minus
theta.
theta.
Pi
Pi
minus
minus
theta is
theta is
correct, sir.
correct, sir.
Pi minus theta is correct. But, okay. Pi minus theta will somewhere be here, right? That is why I'm asking you whether you know principle. See, the thing is, below the below the upper half plane, you have to move in the counter in the clockwise direction. So you move in the clockwise direction. Okay.
So minus
Minus
pi
pi
minus
minus
theta.
theta. No, all of you seem confused. Okay, let us say this is your theta. Okay, then what should be the value? Like this is your minus pi, right? All of you know.
Yes,
Yes,
sir.
sir.
So, and if this is your theta, so what are you doing exactly? Minus pi plus theta, correct?
Yes,
Yes,
minus pi
minus pi
plus
plus
theta.
theta. Yes, sir, correct.
So why don't you say it like this? And this is in the range, right?
Yes,
Yes,
sir.
sir.
Yeah.
Yes,
Yes,
sir.
sir.
This is, I don't know, like why was this so? Okay.
So
So
guess is
guess is
correct,
correct,
but
but
Hmm.
it
but
tells
here
something
something
wrong.
wrong.
What? Just a minute. Just a minute. हेलो भाई, क्या है नाश्ते में? अच्छा भाई, हाँ ला दीजिए भैया, ज़्यादा रख लेना थोड़े. Yeah. Hello. Sorry, a call. Yes, Pile, you were saying something.
হ্যাঁ
হ্যাঁ
স্যার,
স্যার,
আমি
আমি
বলতে
বলতে
চাইছিলাম যে
চাইছিলাম যে
আমরা
আমরা
ঠিকঠাক
ঠিকঠাক
গেস
গেস
করেছি
করেছি
কিন্তু
কিন্তু
বলতে
বলতে
পারছিলাম না
পারছিলাম না
বুঝি।
বুঝি।
हाँ, लेकिन वो बात ठीक है, तुमने जो बोला था वो ठीक था, बट इसी में देखो मैं क्या कहना चाह रहा था. तुमने पाइल ये बोला था, राइट? पाई प्लस थीटा.
यस
पाइल
यस
इस,
सर।
सर।
बट इसी में अगर तुम 2 पाई घटा दोगी तो आर्ग्यूमेंट तो चेंज नहीं होने वाला, 2 पाई ऐड करने पे या घटाने पे, वी नो, राइट?
राइट।
राइट सर।
बट देन इट विल बी इन द रेंज, करेक्ट?
হ্যাঁ
হ্যাঁ
স্যার।
স্যার।
हाँ. So this is what I was trying to tell you. Once you get some value, you keep on adding or subtracting minus 2 pi. Okay, so that you will get in the range.
Yes,
Yes,
sir.
sir.
Yeah. Oh, sorry, here I have done some terrible mistake and none of you are saying this to me. This is my theta, right? Yeah.
স্যার
স্যার
আমি
আমি
বলেছিলাম
বলেছিলাম
একবার
একবার
যে
যে
ওটা
ওটা
পজিটিভ
পজিটিভ
এক্স
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 অ্যাক্সিসের
অ্যাক্সিসের
সঙ্গে হবে,
সঙ্গে হবে,
কিন্তু
কিন্তু
আপনি
আপনি
তাও
তাও
दर्शना,
এড়িয়ে
तुम
গেলেন।
तेज बोलो. ठीक है.
Okay,
ओके
sir.
सर।
Sorry, Pile. Yeah, sorry for that. We all can make mistakes, right? We all are learning. Okay.
স্যার ঠিক
ঠিক
আছে,
আছে,
কোনো
কোনো
অসুবিধা নেই,
অসুবিধা নেই,
কিন্তু আমি
কিন্তু আমি
ঠিকই
ঠিকই
বুঝেছি।
বুঝেছি।
हाँ.
আপনি যাই
যাই
বললেন
বললেন
আমি ঠিক
दारुण
থেকে
है.
বুঝতে
বুঝতে
পারি।
পারি।
Okay. Yeah, now all of you have to tell me this correctly, huh? Otherwise I'll kill you. So if this is your theta, what should be the argument z? All of you. Oh, this is principal argument. Okay, so I'll write capital A.
Minus theta.
Exactly. Argument z should just be minus theta, right?
2 pi
2 pi
minus
minus
theta
theta
minus
minus
2 pi.
2 pi.
So pile what it will be finally, it will be minus theta, right?
Yes,
Yes,
sir.
sir.
Hmm. So this way we have covered every possible argument z, right? Now you know how to calculate.
Yes,
Yes,
sir.
sir. Yeah. So now I write something and you'll tell me if this is correct or not. Remark. This principal argument of z, the principal argument of z is a single valued function. Correct? Yes or no?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
So what I want to say, and it is a function from c minus 0 to some real, right? It is a real valued function. Yes or no? Because it is an angle. Correct?
Yes, sir.
Yes, sir.
Z goes to argument z. So second, if given any argument, so okay, I am writing something, you will tell me whether I can write it as this or not. So log z, we have seen how do we define it. It is ln mod z plus
I argument Z.
argument z, this small argument z. Okay, z not equal to 0. Now can I write it as plus iota principal argument of z and then plus 2n pi? Correct?
Correct, sir.
Correct, sir.
If you keep on adding or subtracting 2n pi, you will get the complete logarithm, right?
Yes,
Yes,
sir.
sir. But you know that this part is a single valued function now. Yes or no?
Yes,
Yes,
sir.
sir.
Sir,
Sir,
argument
argument
is
is
single
single
value.
value.
Because we have and this part we call as principal logarithm. Okay, plus 2n pi. So do you all agree with this? That
Yes,
Yes,
sir.
sir.
consequently, consequently, considered as a function, if this log z, if we consider this as a function from c minus 0, right, to c, z goes to log z, this is a single valued function. All of you agree?
Yes,
Yes,
sir.
sir. And have we lost anything? So this is third. And fourth is, you see what will be exponential of logarithm of z. Can anyone tell me? Even with this definition,
Z.
Z.
z only, right? So in this sense we have not lost anything. Correct? That property what we want from our logarithm is intact. Yes or no? We
Yes,
started
sir.
with this aim, right? Exponential of some function should give me the identity. We started with this motivation. But the problem was it was a multi-valued function that we started with, and now we have made it a single valued function. So do you have any doubt until now?
सर इसके होलोमॉर्फिक फंक्शन और कंटिन्यूटी के बारे में क्या बोल सकते हैं?
अभी बोलेंगे दर्शना, एक एक करके सब बोलेंगे.
ओके.
Okay. So yeah. So now you agree, right? So this is a single valued function that we have defined. Now second step should be continuity, right? So a natural question should come into the mind, that is this function log. Where is it defined? On c minus 0, this function log z on c minus 0 continuous. Correct? Yes or no? We have defined a function, so we can check for its continuity. Rajesh, can we do that? Like, this should be the next step, right?
Yes,
Yes,
sir.
sir. Yeah. So now I'm going to do something. So if you have any doubt, please ask. Okay. As I said, I am in no hurry. Okay. Now I want all of you to focus here. So I will be dealing with this argument z first. Okay. So see, in log z, what is the definition of log z? Log z is ln mod z plus iota principal argument of z. Correct? Yes or no?
Yes.
Yes.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir. And we know that log if log z is continuous, on c minus 0, if and only if argument z is continuous. Do you all agree?
यस
Yes,
सर.
sir.
Yes, sir.
Yes, sir. See, if argument z is continuous, then we know this part is always continuous, right? This part is always continuous. So if argument z is continuous, then log z is a sum of two continuous function. Okay? And conversely, if log z is continuous, then you can write your argument z as my log z minus ln mod z something. And this is continuous. This is continuous. So argument z has to be continuous. Yes or no?
Yes, sir.
यस
Yes,
सर.
sir.
Yes, sir.
So the continuity of log z boils down to the continuity of argument z, right?
Yes,
Yes,
sir.
sir. Yeah. Okay. 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 Now let's say if you take any point here, okay. So I can have a sequence. I can have a sequence which converges to this point in the second quadrant. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Hmm. Just a minute. I think my screen has frozen. I have written. Yeah. Now it works. So let this point be, let's say, W, and this sequence be W n. And because it is in second quadrant, so we will write 2 above. Or let us use alpha n. Okay. So what are we trying to do? Let W belongs to C minus 0 such that, or basically I can write as W belongs to minus infinity to 0, right? This is the real axis. Now,
Yes.
then, so this is first. Then there is a sequence alpha n in second quadrant such that alpha n converges to W. All of you agree with this? As n goes to infinity.
Yes.
Now, if let us assume argument z is continuous. Argument z is continuous. So sequential criteria,
Argument of Z then converges to argument of Z.
argument of W.
Of W.
Sorry, W. Sorry.
Yeah,
Argument of
it is.
W.
Yeah. So okay, now if you know, like, what should be the argument of alpha n? What should be its limit? So here is minus pi, right? So my question is, what
Sir,
is
I don't understand what is
limit?
alpha n.
No, you can take it anyway. Argument alpha n. What should be its limit? What should be this value?
Minus pi.
Minus pi. Why?
एंगल कितना होगा ना W पे?
No. Okay. Okay. You tell me what is this angle? Like. Darshana, no, what I want to say, it will be pi minus something, right?
5 minus.
Zero.
No, no. Okay, what I want to say, alpha n will be, shouldn't this limit be
Pi.
pi? This is what I want to say.
Yes, sir.
Because we know in the second quadrant, what is the limit? Limit is pi minus theta, right?
Yes, sir.
Now, each of this alpha n, this argument will be some pi minus theta n, correct?
Yes, sir.
And what was this theta n? This theta was this angle. Oh, no, here I have done something wrong. Just a minute. You guys have confused me. What should be the theta here? This is what I'm thinking. Some pi was this. If you remove some theta, yeah, theta should be this. Yeah. No, I was correct, Pile, back then. Just a minute, hold on, guys. You think of this.
एंगल तो सबसे पॉजिटिव रियल एक्सिस के संग ही इक्वल. স্যার আপনারা আনমিউট হয়ে গেছে. সরি স্যার, মিউট করে ফেলেছেন আপনি.
Yes. So, yeah, exactly. So, this angle has to be then pi minus theta, na? Pile?
হ্যাঁ স্যার.
Yeah, so that is why I'm saying, yeah. No, that was correct. I was earlier. All of this clear to you? Like, what was the mistake? So, this theta here is the angle. So, like here you see this theta will keep on decreasing, right? This theta n will go to 0. This first. So this will be your theta 1, then this will be your theta 2, and then this will be your theta n. So it is keep on decreasing, right?
Yes, sir.
So it will go to 0. This limit of theta n will go to 0. Hence, this limit will be pi. All of you agree with this?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
with the same logic, we can start from here, right? I mean, we can construct a sequence of beta n which will converge to w, correct? Yes or no?
Yes.
So
Yes, sir.
we will have a alpha n in second quadrant, beta n in third quadrant, such that beta n also converges to w, and this we know that and argument of beta n converges to argument of w. All of you agree with this?
Yes.
Here we have seen, because argument of w, which by this case will be limit argument of alpha n, it should be pi, right? And from here we can see that argument of w will be limit n goes to infinity argument of beta n, correct? Yes or no?
Yes, sir.
Now can
Yes, sir.
anyone tell me the limit of the argument of beta n?
Sir, minus pi.
How?
Minus 5, sir.
How? We can see in the third quadrant how was the angle calculated? It was minus pi plus theta, right?
Yes, sir.
So here it will be minus pi plus theta 1.
Theta decreasing, so it tends
Exactly.
to
Yes.
minus.
So all of you get it why it should be minus pi?
Yes, sir.
So so this will be minus pi. So this 1, let this be 1, and this 2. They are a contradiction, right?
Yes.
Gives a contradiction. And this whole, so what do we say? Argument w is not continuous on minus infinity to minus 0. Yes or no?
Yes. Minus
Because
infinity to 0.
because w was an arbitrary point on the negative axis. Yes or no?
Yes, sir.
Yes.
Now why did this happen on this line only? Can you tell me? See, you start with minus pi, right? And when you come after a revolution, just a minute. Yeah. Oh, I am doing some terrible thing today. Yeah. So you will land up as pi here. Yes or no? All of you agree with me?
There's
Yes,
pi,
sir.
Okay,
pi and minus pi on the
let
same
me explain
point.
again. Okay, what is your principal argument value? It is minus pi to pi, correct?
Yes, sir.
So it means you are starting with, if this is your axis, you want your value to be starting from here minus pi, and then you make a complete revolution of 2 pi. This is my 2 pi revolution, right? Full circle is 2 pi, correct? And then you will
Yes,
land up here as pi. So on this line you see you have two values, minus pi and pi. I mean, uh, intuitively.
I understand.
Darshana, Rajesh,
Yes,
Thangeshwaran,
sir.
Yes, yes,
is
sir.
this clear to
Yes,
the
sir.
rest of you? So the
Yes,
problem
sir.
is this problem will not be anywhere else, right? Except for this line.
Yes,
Yes,
sir.
sir. Exactly. So this is called the overlapping line. Or, like this is the branch. Not branch, I would say. Branch is a certain definition. Uh, so
Sir,
let
this is part.
while your voice is breaking, আমি বুঝি না পায়েল.
Sir, this is branch cut.
Yeah, we will see all of that. Huh? Just step by step. Okay. So now the conclusion is that this log z is continuous on c minus. Oh, I have to. Sorry. No. What I want to say. I, I have to include zero here also. No. So minus infinity to zero. Do all of you agree with this?
Yes, sir.
Yes, sir.
No,
No,
sir.
sir.
Because
Because
argument of
argument of
omega is
omega is
not
not
continuous. So
continuous. So
how can
how
we
can
say
we say
log z
log
is
z is
continuous?
continuous? No, we have removed that part. On the negative axis, it was not continuous, and I am taking everything other than that.
Okay,
Okay,
minus
minus
pi
pi
to
to
pi,
pi,
minus
minus
infinity to
infinity to
0.
0. See, the problem was at this line only, right?
Yes.
Yes. And what is this line in minus infinity to 0? In the real
Okay.
sense. Yeah.
Yes.
Yes.
Negative
Negative
real
real
axis.
axis. Negative real axis. And this is the largest domain. Right? It is a domain, first of all, right? Why it is a domain? Because it is a complement of a closed set. Minus infinity to comma 0 included is a closed set. So this is a domain. So this is a domain actually. And in fact, you can see this is the largest domain on which log z is going to be continuous. Okay? All of you agree?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. So now we define the branch of logarithm. I'll just take 10 more minutes. Actually, we have defined above. Let If you are given with a domain in complex plane, then now what is a branch of branch of logarithm? It is a continuous function. It is a continuous function f. A continuous function f from G to C is called a branch of logarithm if e of fz is z for all z in G. Okay, is this clear to all of you? Is this
Yes, sir.
definition clear? And one remark, by definition we know that 0 must not be in z G, right? Because if 0 is in G, what does it mean? Something like should this happen, right?
Yes, sir.
if 0 belongs to G. But we know exponential can never take value 0.
Yes,
Yes,
sir.
sir.
Okay. So by the very definition, the domain should not contain 0. Now we have seen one example of this. We have seen one example of this. So if you take G equal to C minus 0, then this principal logarithm, then the log Z is a branch of logarithm. Am I correct? Yes or no? Do all of you agree with this example?
सर मुझे एक बार बोलूंगा डेफिनेशन का
Okay. देखो definition क्या है? First of all, what was the aim? Pile. What was the aim that we started with? Ah. So this was our intuition, right? This we wrote down. Given a domain omega, we want to construct a function f which is continuous on omega such that e power fz is z. Pile, do you agree with this? We started with this.
यस सर
Now this very continuous function is called branch of logarithm. That's it. Okay.
ओके सर
Now you read the definition of branch of logarithm. Take your time. Let G contained in C be a domain. Then a continuous function on G is called a branch of logarithm if exponential of that function is identity. Okay.
ओके सर
Yeah. And we have seen if you choose your domain to be C, not C minus 0. Sorry. Hey, guys, what are you doing? Darshana, where is your focus? This should be minus infinity comma 0. If you
सर
take
मैं
this
बोल
domain.
तो रही थी, कंफ्यूज हो रही थी.
No, no. Yeah. No, just
सर जीरो इंक्लूड होगा या नहीं होगा इसमें?
जीरो इंक्लूड नहीं होना चाहिए ना, क्योंकि हमने देखो डेफिनेशन में क्या आ रहा था, ln mod z आ रहा था, राइट? दिस पिंक बॉक्स is ln mod z defined for z equal to 0. Real
No.
logarithm is not defined na for 0.
Yes.
Pile, do you agree with this?
यस सर
Yeah. Thangeshwaran?
Yes, sir. Yes, sir. Please.
Okay. Now the question is, so the next question should be the last question. This is a big topic. It's almost impossible to cover it in 1 hour. Is log z holomorphic on C minus 0? On C minus on this domain. Correct? This should be the natural question, right? This should be the natural question,
यस
right?
सर
Now I'm writing a theorem whose proof you have to do, which will answer this question. Okay, this theorem you must have seen. This is called some version of inverse function theorem. Okay, let omega 1 omega 2 be two domains, and so this is how we have uh, on omega 1 we have a function f. Okay, and from omega 1 to omega 2 we have a function f. Then from omega 2 to C we have a function g. Whenever you have two such function you can always compose. Yes or no? Correct?
Yes, sir.
Yeah. So this function is called composition, fog, right? Or gof, sorry. First f then g, yes. Such that, so we can compose such that this composition is identity function. फॉर ऑल z in, z कहाँ से आएंगे फॉर ऑल z in? फॉर ऑल z in?
C minus
No.
RS infinity to 0.
Oh, no, you read the statement of the theorem. It is g of f of z. So z is coming from the domain of f. What is the domain of f?
Omega 1, sir.
Omega
Yes,
2.
omega 1. Right? Yes, please mute yourself. Now, the theorem says if g is differentiable on omega 2, if g is differentiable on omega 2 and and g prime z is never 0. This is never 0 for any z. For any z in, यहाँ पे z कहाँ से आएंगे? What is the domain of g?
Omega 2,
Omega
sir.
2, sir.
Very good, omega 2. Then two things happens. Then f is differentiable. Then f is differentiable. Second, the derivative will be f prime z. It will be g prime of f of z. Okay, this theorem I am not doing the proof. Okay, this theorem you can find it anywhere. Okay, now you see we are going to apply this theorem. What did we have? What did we have on C? Okay, I'll write here only so that it is clear to you how we are going to apply this theorem. So blue pen means it is not a part of this theorem. Okay, now if you take f to be log z, you know this principal argument, this c minus, right, this was a continuous function.
Yes, sir.
Yes, sir.
Yeah, one more
Yes,
thing.
sir.
Yes, sir.
One more thing, this f and g, they are continuous function, and g we have taken differentiable, so it has to be continuous. Now, and from here to here, you can take exponential function, correct? Yes or no?
Yes,
Yes,
sir.
sir.
Now, what is their composition? If this is your f and this is your g, what is g of f of z? It is exponential of log z, which should be z,
Jed.
Jed.
correct? So this
Yes,
satisfies
sir.
the first hypothesis of this theorem. Just give me a yes or no.
Yes, sir.
Yes, sir.
Now, what is g? G is e power z. Now come to the next hypothesis. It says g is differentiable. Exponential is differentiable, yes or no?
Yes, sir.
Yes, sir.
Now the next hypothesis, g prime is never 0. What is the derivative of exponential? It is the exponential itself.
Yes, sir.
Yes, sir.
It
Yes,
is
sir.
never 0.
Yes, sir.
Yes, sir.
No,
No,
sir.
sir.
So what will this theorem say? That log z is differentiable, right?
Yes, sir.
Yes, sir.
Log z is differentiable on which domain we have started with? This domain, correct? And because
Yes,
it
sir.
is differentiable at every point of this domain, which means it is analytic.
Yes.
Yes. Yes, sir. Yes, sir.
Because if a function is differentiable at every point of a domain, then it is analytic. Hence, this principal logarithm is analytic. So Darshana, does that answer your question? And not only that, Not only that, this was the first conclusion. Second conclusion is the derivative d by dz of this complex logarithm. What does it say? It is g prime f of z. Yes or no?
Yes, sir.
But what is g prime? It is exponential only. So this is exponential of log z. Do all of you agree with this?
Yes, sir.
Because gz was ez. So the derivative turns out to be 1 upon
Z.
z. Exactly.
J.
For all z in. So there is one more reason to believe that we should avoid 0. Okay.
Yes, sir.
And this property is similar to your to the property of to the property of real logarithm. Yes or no?
Yes, sir. Yes, sir.
Exactly. So I think this was about the complex logarithm that you should know, at least the basis. So for example, just a few questions. I'll stop recording. Just a minute.